Hello, problem solvers. Today we're going to work on IXL assignment Q5F, identify equivalent expressions version 1. So let's talk about what that even means, equivalent expressions. Well, equivalent is another word for equal. And if we kind of look at the beginning, we can see that it starts off the same, equal, EQU, equivalent, EQU. So there's lots of different ways that you can come up with things that are equivalent, that are equal. One of the most basic examples would be like 2 plus 5 and 5 plus 2. Both of those are equivalent because they end up equaling 7. It's just two different ways of writing it. And one, the 2 comes first, and the other, the 5 comes first. So sometimes equivalent expressions can be just like that. It's a reordering of one of our properties. It's a reordering. Other times, we can use simplification to come up with equivalent versions. So if we think of fractions, 1/2 and 2/4 are equivalent fractions. It's just one is simplified, one is not, but they both represent that same value. We can do the same thing when we're combining like terms. Here's a fun little example. So instead of using variables, we've used pictures, because remember, a variable just represents an unknown value, something that we don't know the value of. And sometimes, especially if there's a word problem attached, it kind of can help a little bit as a label, a little bit as a reminder of what it is we're trying to find. So in this case, if we have a fruit basket here of 14, I don't know, peaches, or maybe that's a tomato. I don't know. And then 8 lemons, 5 avocados, but then we take 6 of those tomatoes away. We add in 4 more avocados and we take out 2 more lemons. If we were to combine these with all of the like fruits, the things that are the same, we would have our total in the fruit basket at the end. And notice that when we're combining like terms, yes, they all may have a fruit attached, but they're different kinds. So we keep it separate. We have 8 of the tomatoes, 6 of the lemons, 9 of the avocados. Now, if we look at that with variables, because I don't know about you, but I'm not an artist. And even if I was, I don't know, maybe if I was, I would enjoy drawing, those pictures for every single one. But using a letter, using a variable is a little bit faster. So if we had a problem like 4a plus 5 plus 2a minus 3. We can combine the things that are the same. So our 4a and 2a are the same because they have the same variable. We have 6 a's. The 5 and the minus 3 are the same because they're both constants. They're numbers without a variable. If we combine those, it becomes a 2. So not only have we combined like terms, we've simplified it. We've created an equivalent expression. So our top expression here, 4a plus 5 plus 2a minus 3, is equivalent. It is representing the same value as 6a plus 2. They represent the same thing, just one is simplified, one is not. And when coming up with equivalent expressions, the distributive property might also be used, because if we distribute that 6, instead of having 6 times the quantity of x plus 2, well, those parentheses tell us multiplication, so we take 6 times x and 6 times 2, giving us a simplified answer of 6x plus 12. Well, 6x plus 2 and 6x plus 12, or sorry, 6 times the quantity of x plus 2, and then 6x plus 12 are considered equivalent. One is simplified, one is not, but they represent the exact same thing, just a different way of writing it. All right, hopefully that little recap helped, but when we get to IXL here in a second, you could be using any of these things. You may just have to simplify like fractions or reorder our numbers. You may have to combine like terms. You may have to use the distributive property, but what we're looking for are equivalent expressions, things that are equal through the process of simplifying. All right, here we are on IXL assignment Q5F, identify equivalent expressions. version 1. Please remember that on IXL, they have a couple great resources for you. You can learn with an example. This would be like what you would see in a textbook, step-by-step directions, or you can watch a video. Sometimes it helps to hear things from a different perspective to get it to click. So please check those out if you would like a little bit more assistance after this video. All right, we want to know which one of these expressions is equivalent to 6x minus 2s. So we just need to simplify this expression and see which one of these is equivalent. So there's not really any directions here on whether you need to combine like terms or whether you need the distributive property. So that's where this kind of levels up in the challenge, is you have to figure out what needs to be done. Well, when I look at the problem, I don't see any parentheses that would lead me towards multiplication, that would lead me towards that distributive property. But I notice that the 6s and the 2s are like terms because they both have the same variable of an s. So because they're like terms, I can combine them through addition or subtraction. And in this case, it has a minus sign. So 6 minus 2 would lead me to 4s. And look at that. That's one of our options. So that is a simplified version. It is an equivalent expression to my original problem here. All right, we want to know which expression is equivalent to 3r minus 9r. Once again, I don't see any parentheses that would require me to use the distributive property, but I do have like terms. The 3 and the 9 both have the variable r, so I can combine them. I need to follow the sign, 3r minus 9r. So we're taking away more than we started with, and that means our answer is going to be negative. That would lead us to have negative 6r. Another way you can think of this is if ever you see a subtraction sign, you can rewrite it as adding the opposite. Sometimes you may think of this as keep, change, change. So we could rewrite this to be 3r plus a negative 9r. When we follow our rules for adding integers, when the signs are different, we subtract and keep the sign of the heavier number. 9 minus 3 is 6. The 9 is heavier. There's more of them, leading us to that negative 6r. So no matter which way your brain thinks about those subtraction signs, those negatives, it would result in the same answer. All right, let's look at this problem here. Which expression is equivalent to negative 3 times negative 2a? All right, when you see your parentheses, remember those parentheses are like a double agent. They have lots of different things they could mean. They could be a grouping symbol. They could be multiplication, or they could be both. So I know that they are a grouping symbol if I have lots of stuff in there. If I have lots of addition signs, division signs, lots of different terms within the parentheses. In this case, I only have one term. I have my variable term of negative 2a. And then there's a number right outside the parentheses. So in this example, it simply just means multiplication. So let's multiply to simplify and see what our equivalent expression is. Remember that a negative times a negative is a positive, which would result in a positive 6a. All right, let's check this problem out. Which expression is equivalent to 3 times the quantity of t plus 3? All right, you know how we were just talking about those parentheses and lots of meanings? Look and see how this is a little different from that last problem. This time when we have our parentheses, we have more than one term on the inside. We have a group of things on the inside. So they are meaning grouping symbols. But when I look inside the grouping symbols, can you add t plus 3? No, we can't add those because they're not like terms. One's a variable, one's a constant. But thankfully, we have a 3 on the outside, meaning these parentheses are also representing multiplication. This 3 is being multiplied by that entire group. So that 3 is being multiplied by everything inside the parentheses. This is where our distributive property comes in. We're distributing, we're passing out via multiplication to everything on the inside. So we can take our 3 and multiply that by t. Bring down your plus sign. 3 times 3, which would be 9. Is there anything else we could do? Nope, we cannot do anything else because they're not like terms. The 3 has a variable, the 9 does not. We have a variable term and a constant term. They're not the same. They cannot be added. That is our final answer, our equivalent expression. Now, if there were other choices available here, if something said 9 plus 3t, that would be an acceptable answer as well. That is also equivalent. It's written opposite, it's flipped, but it's still the same thing because the 9 is positive in both cases. The 3t is positive in both cases. So it represents the same value. It's just one is written with the variable first, the other is written with the variable term second. So if you have any, like that, note that you might have to look for that in terms of equivalent expressions. All right, let's do 2 more together, and then you'll be on your own. All right, here we have which expression is equivalent to 3 times the quantity of negative 2t plus 3. I see those parentheses. That's where I want to look. If I look inside the parentheses, I can't do anything there because the negative 2t and the 3 are not like terms. They cannot be added. So that means I'm going to have to use the distributive property. That 3 on the outside is going to be distributed, is going to be multiplied to everything on the inside of our parentheses here. So 3 times a negative 2t would be a negative 6t. Bring down our plus sign. 3 times 3 is 9. And if we look at our different answer choices, that one matches. That is an expression that is equivalent. That is a simplified form of our original problem. All right, let's have our last problem here. Which expression is equivalent to 8 times the quantity of b plus 6? All right, first thing I'm going to try is use that distributive property. That's just kind of what comes natural to me because I see there's parentheses, but I cannot do what's inside the parentheses. So 8 times b would be 8b. Bring down our plus sign. 8 times 6 would be 48. None of those answers match. If we look here at our original problem, this is going to be like one of those that we did in the very first part of the PowerPoint where maybe it's just flipped around. Maybe it's the exact same expression, just written in a different order. So we need to see what would be equal. There's a couple different ways you could do this. Option 1 would be looking through, and maybe you can find it that way. But if you can't, you could always apply the distributive property to your answer choices and see which one would give you 8b plus 48, or a very similar version, an equivalent version. But when we look at our first one here, I notice that the difference is I'm multiplying by a 6. Well, in our problem, we're multiplying by an 8. And if I were to multiply by a 6 instead, I would get 6b. That's definitely not the same. That's not equivalent to 8b. Not going to work. If I look at option 2 here, inside the parentheses, we have a multiplication sign instead of an addition. Well, that's definitely going to create a different problem because you can multiply unlike things. So that would end up being 8 times 6 times b. Drastically different answer. That would be 48b. Not going to work. If we look at our third one here, the only difference is the b and the 6 have flipped places inside the parentheses. That looks promising because we're allowed when it's addition and we're allowed when it's addition, our commutative property lets us flip those. So if we were to distribute, just to double check our work, 8 times 6 would be 48. 8 times b would be 8b. Yeah, that's the exact same thing, just written flipped, but the 48's positive on both sides. We have an 8b that's positive in both places. I believe this is our answer, but just to be sure, let's check that last one out. Oh, that last one's not going to work either because just like the first one, I'm multiplying by 6 instead, and that would give us a 6b, which is not going to work. So be careful as you go through this. There may be different things you need to look for to determine the equivalency, but when it comes to the root of it, I would first simplify, see if that resolves the answer. If not, and if it's a problem like this, you may have to look a little closer at your answer choices to see which one is written differently, but it's still equal. It would still result in that same answer. It's just maybe dressed up a little or in a backwards way. All right, so it is your guys' turn to check this out. I believe that you can do it, but as always, if you need some help, check out IXL's video, send me an email, and I'll be happy to work with you. Good luck, guys.